Today I'm going to talk about solving systems of linear equations. We'll explore the tools and techniques used to handle these systems, focusing particularly on elementary row operation and their role in achieving row action forms, which are crucial for solving this system efficiently. Elementary row operation. There are three main types of operation we can perform on rows in a matrix to help solve linear equation. First, row interchange. This involves swapping two rows. This operation is useful for rearranging the equations in a system to a more manageable form. Second, row scaling. In this operation, we multiply all elements in a row by a non-zero number. This can help simplify the equations. Third, row addition. This operation allows us to add a scaled multiple of one row to another row. It's particularly useful for eliminating variables from equations to simplify the system further. Row action form and reduced row action form. When we use the above operation to solve linear equations, our goal is often to transform the matrix into what's known as a row action form. In this form, all rows consisting entirely of zero are at the bottom. Each leading entry, the first non-zero number from the left in a row, is to the right of the leading entry in the row above it. Below each leading entry, all entries are zero, helping to isolate variables in each equation. If we go further and make each leading entry 1 and ensure that this leading one is the only non-zero entry in this column, then the matrix is reduced row action form. This form makes it even easier to read off the solutions to the system of equations. Solving linear systems. To solve a system of linear questions, we often form an augmented matrix that includes both the coefficients of the variables and the constant from the right-hand side of the equation. We then apply the elementary row operation to transform this matrix into its row action form, or ideally, it is reduced row action form. The solution to the system, if they exist, can usually be read directly from the form of this final matrix. Elementary matrix. An interesting aspect of row operation is that each can be represented by multiplying the original matrix by what's called an elementary matrix. These matrices are derived from the identity matrix by applying a single elementary row operation. Theory on consistency of linear systems. A key theorem regarding the consistency of linear systems states that the system of equation is consistent, meaning it has at least one solution. If the row action form of its augmented matrix does not conclude a row that, after the vertical bar representing the equal sign in each equation, has non-zero entries, while all the entries before the bar are zero. This would indicate an equation like 0 equals non-zero number, which is impossible and hence indicates no solution exists. By understanding and applying this concept and techniques, we can efficiently solve many systems of linear equations, uncovering the relationship between variables and gaining insight into the problems we're investigating.